I've used simple arrays a number of times in this course, but I'd like to talk a little bit more about them. They're one of the easiest ways to store ordered data in Java, but there are certain limitations. I'm working in the project Simple Arrays, and I'll add a bit of code here, declaring an array of primitive values. Arrays can point to any kind of variable, primitives or objects. I'll declare a set of integers. I'll start with the data type int, and then add a pair of brackets. And then I'll set a name for the array, ints. You can actually place the brackets either after the data type, or you can place them here after the array name. You shouldn't do both, but it's preferred to place them after the data type. Now I'll initialize the array's value with a pair of braces, and I'll add in a comma-delimited set of values that match the data type, 3, 6, and 9. This array now has 3 values. The array is not resizable. Once it's been set, its size can't be changed, but you can change the values at each index position. Next, I'll use an incremental loop, and I'll loop through the array, and for the second part of the loop declaration, I'll set a ceiling of ints.length. And then within the loop, I'll output the value at that position. So I'm starting at 0 and going through 2. And the result is outputting values of 3, 6, and 9. Now let's see what happens if I change the values. I'll set the values initially as 9, 6, and 3. And then I'll run the code again. And I see that the array order is exactly what I declared. But it's also possible to sort an array. So now I'll use a class named arrays, and I'll call the sort method. Notice that there are versions of the sort method for all the different primitive data types. And there's also a set of methods called parallel sort. Those were added in Java 8. I'm going to just choose the sort method, and I'll pass in the ints array, and then I'll run the code again, and I see that after sorting, the values are back in ascending order, from 3 to 9. An array can point to any sort of object, and I'll use the object that we use the most, a string. I'll declare a string array. I'll name it strings. And once again, I'll start with a pair of braces, and I'll add in 3 values, red, green, and blue. Then I'll use a for each loop to loop through the values. Each time through the loop, I'll be working with the string, and I'll name it color. And I'll get its values from the array that I named strings. Within the loop, I'll output the color value. And I'll run the code, and I see red, green, and blue. But now let's see what happens when I sort that array. Once again, I'll use arrays.sort, and I'll pass in the array. And I'll run the code, and this time I get blue, green, red. The colors are now in alphabetical order. When you declare an array, you can set the initial size without declaring the values. Just as before, I'll start with the data type. I'll use int again, and I'll name this array sized. And now, instead of using braces, I'll start with the keyword new, and then the data type again, and brackets, but this time I'll pass in a numeric value. That's the number of items that I want to be available in the array. Then I'll use a for each loop. Each time the loop, I'll be looking for an integer, and the name of the integer will be value, and I'll get that value from the sized array. With an array of primitive values declared in this way, the values will all be the default for that data type, 0 for the numeric primitives, false for booleans, and so on. But now I'll add a bit of code before this, and I'll set the values explicitly. I'll add an incrementing loop, and I'll loop from 0 to the size of the array, with sized.length. Then within the loop, I'll set the value of the item at that index. I'll use the expression sized and then the index in brackets, and then I'll set the value as I times 100. And I'll run the code again, and I see that the values have been updated as I expect. Notice that the first value is still 0. It's the value I times 100, which is still 0. But then each of the other index values has also been multiplied by 100. Finally, I'll describe how to copy an array using a method of the system class called arrayCopy. I'll declare another integer array, and I'll name this one copied. And as I did before, I'll use the keyword new and the data type again, but I'll set the size of this array to 5. Then I'll call system.arrayCopy. This method takes 5 arguments. The first argument is the original array. Then there's an integer, which is the beginning position from where you want to copy. Then the third argument is the destination array, and then a beginning position where you want to copy to, and a length, the number of items you want to copy. I'll pass in sized and 5, meaning that I want to copy from the sized array starting at index 5, halfway through the array. Then I'll set my destination array to copied and pass in values of 0 and 5. I'm copying to the range starting at 0, going through 5. Then I'll output the results. I'll use a for loop, and I'll start with int, then value, then copied, and then within the braces I'll output the value. Notice I'm reusing the variable value because its scope in the original declaration was limited to this for loop, so I can reuse the variable name. I'll run the code, and I see that my copied array has the values starting at 500.